you're writing a ton of contracts, a smart contract that has so many complexities, have various parts and all of that, it doesn't take long before it becomes too complicated for you to keep up with. So the principle of breaking down, splitting your code into smaller segments for easy maintainability and other kinds of usage, to make it readable, to make it understandable, to make it even appreciable by others, because how smart contract code can look too complicated and very difficult for most people to keep up with. So the idea of needing to learn how to split your contract into smaller segments and making them upgradable is something that you cannot escape as a blockchain developer, as a smart contract developer. So in this particular video today, I want to show you how you can do that. Okay, we're going to upgrade a smart contract. Here is another need why you must master smart contract upgradable techniques. Okay, suppose you have there's a business which are operating from a smart contract, and there's a certain aspect of them that from time to time they would like to change, and the nature of smart contract being immutable once they are on the blockchain. So you can upgrade more functionality, you can add more functionalities to that, you can't do anything. And for example, if they have an aspect of them that has to do with minting, and then they are out of tokens, they would like to deploy a new token or a new project, but under the same name and umbrella. Okay, so doing that whole thing from, it becomes, quickly complicated and, problematic to keep up with in that format. That is why I want to introduce you to this method that I just have been using on how you can write an upgradable contract, or should I say a detachable smart contract, a smart contract that you can attach to another, and then you can also detach it, bring in another one and attach it again. You understand? Of course, they're going to be of the same type, but you can add more feature to the new one that you're attaching and put it together and still work on it. That is, a genius level kind of thing that you can bring it into your smart contract. And that is what we want to show you in this particular, tutorial. Please pay attention. The example of the tutorial that we're going to be using is an excerpt from a course that is available on Dapp Mentors. We just recently released it. Okay. So, and it's also part of another bigger course that is coming on, building a decentralized, cinema system, okay, that has ERC token for 1155 token, the better version of NFTs and all of that. So you do go subscribe to Dapp Mentors to access the source code of this and to watch how I actually splitted the smart contract into multiple file sets and make it in a way that it's easy for one to detach and attach another. Okay, so do check it out. It's on Dapp Mentors Academy. Please, if you haven't subscribed to the channel, all right, I really urge you. I am pleading, please click that like and subscribe button. Don't just be consuming our content without doing something good for the channel. Please contribute to the channel by subscribing, liking the video, sharing it, and also subscribing to Dapp Mentors Academy, where we have the exclusive content. All right, so we really would like you to do that. Hit that notification bell as well so that you won't miss out on any updates that have been released on the channel. My name is Darlington Gospel with over 7 years of experience in the software development industry, and I'm here to help you transition from being a Web 2 developer to a Web 3 developer. So let's jump into the tutorial. Okay, guys, we have some contracts here. Okay, these are all the contracts that we want to work on. Look at it. This is a full contract. Of course, this is a full contract, but I've already done some splitting, and the instructions for going through this to transform this lengthy contract into this short contract here, this tree, and even with this all together, you gotta go check it out on the channel. On our Academy. All right, so we have that there, which will help you to learn how to break your large contract into smaller contracts. Okay, so and this particular tutorial is part of that series, part of that course. All right, so this course is supposed to be for Dapp cinemas, for building a smart contract for a movie, cinema, for them to be able to disburse their ticket as NFTs, and I've been able to finish the working of that smart contract, and the smart contract has now been splitted into three, which is Dapp Cinema, Dapp Ticket, and Dapp Shared. Okay, with a library that is used for transforming content into base 64. Okay, encoding. All right, so we have all those things all together here. All right, this part of Dapp Cinema, this particular one, is responsible for creating movies and creating times, managing movies and managing time slots for those movies, all right, that are going to be aired on the cinema. And then we have Dapp Ticket. Dapp Ticket is basically an ERC1155 token, okay, which is a better version of ERC, collection, okay, that is responsible for the ticket management. Okay, the tickets are basically NFTs, all right, and we were able to design it in such a way that you can mint even badge tickets and so forth. So, but this particular contract basically is responsible for managing the tickets. And then the Dapp Shared is a little contract that provides some shared functionality between Dapp Cinemas and Dapp Ticket. Meanwhile, this is just a library. All right. So we're able to finish developing this and even tested it all together. So what we want to do right now is to show you how you can make this particular Dapp Ticket. The idea is that we want to be able to upgrade this Dapp Ticket and then attach a new one tomorrow. Okay, for example, this is an ERC 1155 token, right? And then later on, we want to be able to add some new features to this and redeploy, then attach it back to this Dapp Cinemas, and then and so on. Or if you actually utilize a max supply in this particular one, okay, want to be able to bring in a new collection in case you're actually doing a collection and you have all this artwork together with it. So let's say the artwork is consumed by this one, then you want to bring in a new artwork into the mix and also bring in a new NFT into the mix as well. You can use this to make a fresh new collection and attach it to this Dapp Cinemas. This is the idea that we're trying to achieve in this particular tutorial. Like I said before, this contract is part of it's part of a project that we're building. Okay, we're building this project. I think, let me connect this. So Ethereum mainnet. All right, so this is part of a project that we're building. It's Dapp Cinemas. This is the front end of it. We're still developing it, and once we're done, we release it as a course. It's supposed to be a place where people will come and buy tickets for their cinemas and be able to watch it, buy as much ticket that they want, be able to manage things like adding of movies, adding of managing of those movies, you understand that, and also you be able to access your cinema, your theater, which we hold the collection of movies that are in your in your account, so long as you're subscribed, you understand. And at each time that you purchase a ticket, that ticket also becomes an NFT for you that you can use later on and trade in exchanges like OpenSea or the swapping external services, which you can do to swap your tokens. You understand? So these are the advantages. These are the things that we are trying to implement in this particular course, and the smart contract for it is what we are discussing at this particular moment. So here's the test script for the smart contract, the three of them, okay, that we have been showing you. Okay, so these are the tests. I just wrote only one test case. Okay, there's really nothing here. This is just a before each. All right, so I'm going to explain that for you, but before I do, let me show you this. I'm going to end this Next.js server, and I'm going to do yarn Hardhat node. I'm going to spin up a blockchain server for what's it called, Hardhat. All right, and after doing this, I'm going to just run this test, yarn Hardhat test. Okay, I just want to show you that everything is working and there is really nothing crazy about this. Only one test case that we've done here. So what is this test case about? All right, so I'm going to run you through this. We are just importing these two libraries. One, expert from Chive testing framework, and what, ethers from Hardhat, which is used for interacting with your smart contract. And we need these two function for converting ethers to we and we to what, and ethers number to we and then we to number. Right, that is what those things they do. We just defined some variables here. This one will hold our cinema contract, this will hold our ticket contract, you understand? And this name, you understand, you do remember that an ERC's token, NFT tokens often have this name and symbol, but because this is let me show you something. Because this is an ERC 1155, okay, it doesn't come with a name and a symbol requirement, so you have to specifically add that. That is why we did it here. Okay, so coming back to this place, we are saying that the name of this token, this first ticket, is going to be what? Dapp ticket, you understand? Or we can say first ticket, you understand? We can call this FTT, okay, FTT, first ticket. Okay, that's a symbol, first ticket. Okay, and then for the movie Dapp cinema contract, we use this to create a movie. We use this to create one-time slot. Okay, so in doing so, we came here and then we got this is a before any one of those tests we run. We want to get this account. These accounts are basically, let me show you this. If you don't know what the account is, the accounts are these numbers here, these accounts that you're seeing here. Those are the accounts. So we are getting the first 1, 2, 3, 4, the first 4, which is this account 0 to 3. That's the first 4 that we're getting there. So that's what we actually specifying by this. Okay. Afterward, we are deploying the Dapp Cinemas contract, which is this one. Okay. And after deploying it, we wait for it to be deployed. We're deploying the second contract, which is the ticket contract. All right. In deploying this ticket contract, we need to pass some parameters because the ticket contract does require some parameters. If you look at the constructor, it requires the Dapp Cinema, that is the primary contract address. It requires a name and a symbol. All right. So that's what we're passing here. The contract address, which is this. Once this is deployed, the contract address will be made available here. That's why we're passing it here. And the token name and the token symbol. So with this, we deploy the ticket. We deploy the ticket contract. Right now, this ticket, this ticket has an awareness of this of the Dapp Cinema contract, right? But the Dapp Cinema contract doesn't have any information about this ticket contract. And the Dapp Cinema contract, if you see, is designed only to allow, you can see this, only to allow the owner of this contract to perform to interact with it. Okay, so other people cannot be able to interact with it except the deployer of this particular smart contract. All right. But we want the ticket contract. There's a place where the ticket contract does interact with the cinema contract, which is in this place. can see we're calling this Dapp cinema contract and we're calling this method here. Okay, this method has been modified in this cinema contract here. I'm just running you through this. I've already created all these things, so we're just running you through so that you can catch up. Okay, so there is a provision we made here, which is to create a new row, a ticket row that enables contracts that are going to be interacting with this particular contract. The ticket contract that is going to be interacting with this, cinema contract. If it possesses this ticket row, then it can access two essential function here, which include the ability to call this function called delete time slot, okay, and also call this function called complete time slot. You can see that they are not owner only function. But there is this requirement here, which is saying that it must have a row. The caller must have a row of a ticket row, and otherwise it will bounce off saying that the caller is not a ticket contract. But we use this function here to grant a new ticket contract the row of ticket row, so that they can interact with this contract. And that is what we are doing here by calling this Dapp cinema contract, this grant contract, grant access, and we are granting this ticket contract access into our cinema contract. This is how we hook up the two contracts together. Otherwise, the two contracts will not be able to communicate with each other. So that is the idea here. And then everything works just fine from then henceforth. All right, now let's create a new instance of this token contract. All right, so this is ticket contract. I want to call this ticket contract 2. Okay, so this will be the second instance, and I want to create new symbols for them. Do I need that? Let's see. Okay, and let's just see this. Let's just see. This is token name to text, symbol. This is second ticket, and we can call it STT. Okay, so let's create a new instance of this ticket. All right, so we're going to create a new instance of it, call it ticket 2, and we're still going to give it this, but the same cinema. Okay, or we're going to give it a new name and a new symbol. And at the end, we want to make sure that it is deployed. So right now, this will be deployed on the network. Okay, so that is a second instance of this particular contract. What about here? Okay, in this first instance, we were able to use, let's duplicate this. I'll call this should confirm first ticket interaction. First ticket interaction. Okay, so I'm going to duplicate this test right now. So this is a second one. Call this second ticket interaction. Okay, second ticket interaction. So what is this about? You see that we're able to everything works just fine. But if, for example, I want to use the second ticket to call this to make a completion. Okay, let's do this again. If I call this, let me open this now, right? I'm just going to close this. Okay, so if I run this test, everything should work just fine. Okay, that is the goal here. So the two tests are working just fine. But if I try to use the second, the second ticket to try to perform this transaction, to call this particular function, it's going to complain. Okay, let's see. Okay, complain saying that caller is not ticket. contract. Okay, caller is not the ticket contract. What happened? What can we do to resolve this? If we actually, you look at this particular function, this is a very important function here. So what if we grant access first to the second contract, before calling this? Let's see whether that works out successfully for us. So let's clean this up, and let's perform this function again. Test. You see, that works successfully. Why did that work? What about after granting this first ticket? Okay, I've granted it. It means that, what about if the initial one, this ticket one, tries to perform this again? Let's see whether it will work out this time again. Let's see. You see, it's failing because it's no longer what it's not no longer the ticket contract. It has been switched with a new one. You get your understanding how all these things flow. So what that means is this is basically what it means now. Okay, that this ticket one is no longer, this particular ticket is no longer the main ticket that is given access to this. Okay, it has basically been upgraded or switched. Okay, remember, ticket 2 is another instance, okay, of this ticket 1. They are the same contract, but there are 2 instances, meaning that I could change some things about it. Okay, for example, what I mean is that if I come here and duplicate this contract, this ticket contract, okay, I'm going to duplicate it right here. Now, copy this and duplicate this. Let me show you something. Okay, call this ticket 2. Okay, and inside this ticket 2, I'm going to call it like this. Then I want you to look at, in this ticket 2, I'm just going to add one function, one extra function. Okay, I'm just going to say I made an upgrade, say added feature. Okay, and added feature is a public function, owner only. Okay, and it just returns. Okay, I could say something like deployer. Okay, it should just return an address. Okay, it should just return address. Added feature. Okay, return. Let's call it return owner. So this should be returns an address. Okay, so we're going to say return owner of. Okay, return owner. Okay, so we'll say view returns. Okay, so this is an upgraded, I added a feature, which is this. This is one feature that I've added to this Dapp ticket 2. So now when I'm actually calling this, I will just use this Dapp ticket 2. Okay, and then let's perform that particular action again, just to prove to you that they are not the same contract. Okay, so they are not the same contract. Of course, this one will fail, because we're actually trying to use that same using ticket 2. Okay, so if we try to call this, let's say result, okay, is equal to await ticket 2 dot, let's call this function return owner. Okay, and we just want to log this off, return result on the console. If you run this this should work out just fine. Okay, you can see the owner here, right? But what if we try to call it in the first one? It will fail, say that return owner is not a function. So because of the ability to upgrade and actually grant the new contract access, we have been given the secret now to actually make new updates, add new features to a new contract, and actually hook it up to that particular primary contract, and everything just works out fine. So this is the secret of creating a detachable contract, creating an upgradable contract, breaking down your contract into smaller pieces. This is the secret that you really need. You understand? And it has been able to, we have been able to achieve that by, using this. Okay. So one more thing I want to do is just say result is equal to, let's say await, call it this ticket contract dot, name. Okay. And then just log out the result. Okay. This is the result. And let's also check out ticket contract 2 and also the name, so that we see that there are two different contracts and not the same thing. You can see the one is first ticket, the other one is second ticket. All right. So this is the secret that you need to be able to design a much more maintainable, a much more upgradable smart contract that is lasting. All right. So this is what I wanted to teach you, how to upgrade your smart contract, in this particular tutorial today. Congratulations for following up this tutorial. And if you want the full source code and assets of this particular project and all that, you can get it on the academy. You can join the academy and get it there. And every other of our course. Currently we are still on promo. We're still giving out every one of our courses, and every of our materials. You can get it accessed. You can access it in our academy. Once you are a subscriber, you gain access to it, including this particular source code and everything for it. You can get it out there, that will help you to understand the intricacies of designing an upgradable contract. Okay, so with that said, my name is Darlington Gospel, and I will see you in the next tutorial.